Oh, yeah. Time for some math.
Polynomials are linear combinations of certain power functions. First off, a linear combination is just a fancy term for add and subtract stuff. Secondly, what do I mean by certain power functions? In the primer on power functions, we saw that a power function has a variable as the base and any constant as the exponent. Polynomials, though, only allow power functions with 0 or positive integers in their exponent. Recall that integers are whole numbers. Shown on the screen are several examples of polynomials. Notice that each term is combined through addition or subtraction. Also, the exponent in each individual term is either 0, which is a constant, or a positive integer. Here are some examples of functions that are not polynomials. In the first case, one of the exponents is negative. In the second case, one of the exponents is not an integer. In the third case, the expression is being divided by a variable. Now that we've reviewed the basics, let's answer the most important question. What are you expected to know about polynomials coming into Math 1320? There are two major things. Number one, you should be able to determine the degree of a polynomial. The degree of a polynomial is the value of the highest exponent. It's also sometimes called the order of a polynomial. Shown on the screen are several examples of polynomials. Pause here if you'd like to try the example yourself. The first polynomial is of degree 6. The second is of degree 3. The third is of degree 8. Let's get back to our list. Number 2. You should be able to expand and simplify equations into polynomials. Let's try an example. Consider the equation y equals 5x squared plus 3 times 2x cubed plus 7x. Pause here if you would like to try the example yourself. We can expand and simplify this equation into a polynomial using the FOIL technique. Multiply the first terms together. Since they have the same base, we can add their exponents. The result is 10x to the 5. Multiply the outer terms together. They also have the same base, so we can add their exponents. The result is 35x cubed. Multiply the inner terms together. The result is 6x cubed. Multiply the last terms together. The result is 21x. All of these terms are then added together. Any terms with the same x power can be combined. The final answer is therefore y equals 10x to the 5 plus 41x cubed plus 21x. The degree of this polynomial is 5. Let's try another example. Consider the equation y equals x plus 2 all cubed. Pause here if you would like to try the example yourself. First, let's rewrite and expand the cubed part of the equation. In other words, let's rewrite the equation as follows. Let's focus on the first two terms and expand them using FOIL. Multiplying the first, outer, inner, and last terms, and simplifying, results in x squared plus 4x plus 4. Now we need to combine these terms with another iteration of x plus 2. This can seem intimidating because there are so many terms to deal with. I like to focus on the first set of brackets and use that as my starting point. Starting with the x squared term, multiply it in order through the second set of brackets. In other words, let's determine what is x squared times x and x squared times 2. Now we're done with x squared. Move on to the 4x term. Determine 4x times x and 4x times 2. Done with 4x. Lastly, determine 4 times x and 4 times 2. Now we're done with 4. Now we can clean everything up. The final answer is therefore y equals x cubed plus 6x squared plus 12x plus 8. Note that there are methods that you can memorize to expand some of these types of equations a bit faster. This involves binomial theorem and Pascal's triangle. But I prefer using this method shown here because 60% of the time it works every time.
Hey, it's Katrina from Prep 101. I really hope you enjoyed that primer. There's definitely more where that came from. Make sure to join the Facebook Study Hub for this course where you and your peers can communicate, ask questions about the course, and get access to free study aids. Use the link in the description box. I hope to see you at our prep sessions. I'll break down the course content for you step by step show you how to solve actual exam questions, and maybe we'll get in a few laughs along the way. Many prep sessions for midterms are free. Yeah, free. Visit prep101.com for details. Thanks for watching. See you soon.